Hi, and welcome to the 6th video of this series where we learn together how to code with Solidity. Today, we've got a special one. We're going to be building a simple auction. Now, the general idea of the simple auction is that everyone can send their bids during a certain bidding period. If the highest bid is raised, the previous highest bidder gets their money back. After the end of that period, the contract has to be called for the beneficiary to receive their money. Now, part of this is done manually, first for security reasons, and then for simplicity reasons. Now in here, as you may have understood, we're looking again at the concept of time, and in general at all the previous concepts that we have learned up until now, or the majority of them, and we're going to be introducing a couple. So let's just get to it. Okay, so as usual, we are in Remix, which is the IDE we've been using from the start. And you see I've created a new file called simpleauction.sol. This is the one where we're going to be creating our simple auction. So as usual, first thing we do is we declare the version of Solidity that we want to be working with, which goes from 0.7.0 to 0.9.0, just as a default. And we create our contract that we call simple auction. Now, the first thing that we're going to do is we're going to declare some variables. And it's quite standard. You know, the first thing we do is we declare variables and then our constructor and our functions. So the variables, the first variables that we're going to create, they are parameters of our auction. So by parameters, I mean variables that will not change state. So the first one is an address that we're going to make public, and it's going to be the address of our beneficiary. Now, a new keyword that I think we haven't introduced up until now is the keyword payable. Now, so far when we've stocked addresses, they were addresses just, you know, without this keyword payable. And this keyword, what it does is it tells Solidity that this address can be used to actually send some coins. It's just this additional security layer that we have to declare here. And then we're going to create a uint that will be public too, and it'll be our auction end time. So it'll keep track of the time at which our auction should end. Then we're going to declare, and actually maybe I'll add this here. So these are our parameters of the simple auction. And below that, we're going to add some variables that are going to be the current state of the auction. And by current state, what do I mean? Well, I mean an address. Oops, sorry. I mean an address that will be public, and this address will be the address of the highest bidder. And the other one that we're going to have is also a uint public, and it's going to be the actual value of the highest bid. So with these two variables, we're just going to keep track of who is the highest bidder and what is he bidding. Then we're going to create a mapping, and this mapping is going to basically keep track of addresses and certain values that they have, so amounts. We're going to make it public, and we're going to call it pending returns. So this mapping is going to be used for keeping track of what address has bid how much and has been outbid, therefore is waiting for getting whatever amount they had bid originally returned to them. We're going to also create a bool, so a boolean that we're going to call ended. This is just going to track whether or not our auction is ended with a simple true or false. Yes, ended, no, not ended. So by default, it's going to be false. And we're also going to have some events. So we've seen events. They allow us to log some data onto the blockchain. So the first event, we're going to call it highest bid increase. So whenever we have an increase in the highest bid, we're going to just keep track of who is the bidder using his address. And we're also going to keep track of the amount that he is bidding. Then we create a second event, and this event is once the auction has ended. So we're going to call it auction ended. And we're going to keep track, so same thing, address, but we're going to call it winner. And we're also going to use uint amount. So when the auction is ended, we're just going to log who is the winner and how much did it cost him. Okay, so these are all of the variables that we need for now. What we need then is, these will not change. So we actually need to first set them a certain value. And we're going to do this in our constructor that is triggered when the contract is just created. Now, as opposed to other examples that we've looked at in the previous videos, this time our constructor function is going to take arguments. And 2 arguments, basically. The first argument is going to be bidding time. And the second argument will be an address, the address of the beneficiary. So you see I'm adding the underscore here. It's to differentiate this beneficiary from this beneficiary. And just to be consistent, I add it here for the bidding time too. Now, one important thing here, though, is that this beneficiary address, we want it to be, of course, and we're going to add it here too, payable. Important to keep it here. And so our constructor function is going to do, very simple stuff. It's just going to set the value of this function, of this variable beneficiary, to the value that is being passed to it. And the next thing it's going to do is it's going to set the value to auction end time. Right here, this variable here, and the value is going to set is, so the current time, block.timestamp, and to this, we're going to add whatever bidding time was set when creating the auction. Okay, so as soon as it starts, we keep track of who is the beneficiary and what is the end time of the auction. And the end time, of course, is counted in seconds. And so we take the current seconds since 1970, 1st January, plus whatever was input here when creating the contract. Okay, so now that we have our variables and we have our constructor, the next thing we need are just functions, actually, to create our functionality. And we're going to create 3 of these functions. The first one we're going to create is going to be a function called bid. I'll create it like this. Whoops. Bid. After that, we're going to create function withdraw. And the last one will be called auction end, just like that. So the first one is, of course, going to allow users to bid. The second one is going to allow users that were overbid to withdraw whatever coins they send that cannot be used for this. And the last one, auction end, is going to be there just to actually end the auction once the time is done and send the funds to the beneficiary. Right here, this guy. Okay, so let's start with the bid function. So first off, of course, we want it to be public. Oops. Public, and we're going to make it a payable function because there will actually be a transfer there. So here we go, and we're going to start with usually what you do, same thing as for a contract, you start by declaring your variables. In this case, we have none. We're not going to need any variable here, but the next part is your conditions, so your if statements, and that's what we're going to start with. And the first if statement is going to be quite simple. It's just, we're going to make sure that we are still within the time of the auction. So we're going to just verify that the block.timestamp is bigger than the auction end time, right? If it's bigger, it means the auction is still going. Oops, here we go. Okay, so if it is, well then we're gonna actually introduce a new concept here too, which is revert. So revert, sorry for the caps. Revert is a function that simply stops the function where it is, right? It won't go further in the code, and it's good just the way it is right now, but we can also send a message saying the auction has already ended. Yeah? So if we are past the auction end time, then the auction has ended. We're going to do something else now. We want to make sure that whatever is being bid as part of this function call is higher than the already highest bid that we have. So for this, we do if message.value. So this is the value of that is sent as part of this transaction. So if it's smaller or equal to highest bid, then we do not accept it, and we revert the user, and we tell him there is already a higher or equal bid. Great. And now if we've passed these tests, well then now what we can do is we can set our highest bidder. We're going to set it to our message.sender, whoever called this function. We're going to then set highest bid. We're going to set it to message.value, which is the value that is being sent when calling this function by whoever is the sender. And then we're going to call our event that we created here. So emit highest bid increase, simply passing the address of the bidder, message.sender, right? So we send the address of the bidder, and then we're going to send what amount he's sending, which is message.value. Okay. But right now, what we're doing is we're simply replacing the values of the highest bidder and the highest bid. What we should, in fact, be doing as well before this is just add the current highest bidder and highest bid, add them to this mapping that we have here. Because this way, the funds of the previous highest bidder will be stocked in here, and he will be able to access them by calling the withdraw function that we will start coding as soon as we're done here. So to do this, first we're going to do a first check, just make sure, in order to not do useless transactions, is we're going to verify that the bidder is different than 0. And if it is, well then we're going to take our pending returns mapping. We're going to go get the highest bidder. And we're going to add the highest bid. Right? This way, using his Ethereum address, the user will be able to get back this value, which was his bid. And once this is done, we can actually go and replace these values with the new highest bid and highest bidder. Okay, so this function bid is done. What we can do now is we can move on to the withdraw function. So withdraw doesn't need any arguments. We make it a public function, and it's going to return a value for us, and it's going to return a bool value, boolean. Okay, so first thing we do is we declare whatever variable we need, and the variable that we need here is an amount, and this amount will be equal to pending returns. We're going to get the value that is saved inside of this, so whatever value we have here, for the address of the current user, whoever is calling this function. Now, if his amount, parentheses, if his amount is greater than 0, which is what we want, obviously, well then what we're going to do is we're going to send his value, pending returns, and message.sender. So his value from the mapping, we're going to set it to 0. because, you know, he is withdrawing it. Therefore, we don't want him to be able to come back and call this withdraw function and again, get whatever bid he had bid. So we're just gonna, first thing we do, set this to 0. And in here, then we're gonna do a new if, but I'm gonna explain something. So once we have set this value to 0, what we want to do is we want to actually send the coins back to the user. Now, to do this, we can do it basically like this. We say message.sender, so we get his address, and we decide to send the amount, right? So we send this amount to this address. Now, the problem is that Solidity will block us right now, because what we need to do for some security reasons is we need to declare this address as a payable address. So we have to just put it within parentheses with this payable keyword before it. Yeah. So now we're saying that this address is payable, and we want to send it this variable, which is amount, which is what we got from our pending returns mapping. But if it fails though, then we, so if for whatever reason we weren't able to send this value, well, then we want to make sure that the user has his account, his amount still available for withdrawal in the future. So how do we do that? Well, actually, we're going to put all of this inside of an if. And we're going to say if, no, this, but we want the opposite of this. So because this says if this is sent, so if true, then do that. But what we want to do if it is not sent. So if it is false, and the send function, if it fails, returns a value false. So actually what we can do is if we add an exclamation mark here, it says that if this statement is not true. So you see how when you write different from as opposed to equals, right? Well, in here we just keep the exclamation mark. So if this is not true, then we're gonna go for pending returns. We're gonna get whatever exactly. So for his address, we're gonna set the value to amount. So in case the payment didn't go through, then his value inside of this mapping is back to what it was. Simple enough. And we're going to return false, as in it failed. And here, if it did work though, we're going to return true. Okay, so that's our withdraw function done. And the last one that we need to do is our auction end. So this one doesn't take any argument either, and it's a public function. That's all we need. And we're gonna say that first thing, we need to make sure that the auction, so the current time is higher than the auction end time. So I'm gonna do if block.timestamp. So the current time, block.timestamp, is smaller than the auction end time. It's smaller than it's not what we want. It's bad. Therefore, we're going to revert the user, and we're going to tell him that the auction has not ended yet. Okay? Great. And the next thing that we need to do is we just want to make sure, and we're going to be using this Boolean here, we're going to make sure that our auction hasn't finished yet. So how do we do that? Well, basically, we just add a new if, and we say if ended. So if this value is true, which right now is not, it's false. If it's true, then we're going to revert the user and tell him that, well, the function auction ended has already been called. Already. Okay. And then we do what we need to do. So the first thing that we're going to do is, of course, if we pass these checks, well, then we're going to set our value of ended to true. So we change it from false to true. And we're going to call one of our events, which is the fact that our auction has ended. So auction ended, and we're going to pass through the highest bidder. So the address of the highest bidder, as well as the highest bid. And the last thing we're going to do is we're going to send the funds to the beneficiary. To do this, beneficiary, so we take the address that we saved here, dot transfer, and we're going to transfer him the value of the highest bid. Highest bid, there's a bit of a problem. Okay, so you see I'm using transfer here, and here we use send instead. Well, transfer and send are in fact very similar functions. They cost the same amount of gas, and they do the same thing, which is in the end, whatever address we chose here will receive the value that we input here. The difference though, and it's an important one even in the way we've used it here, is that send will return false. If it fails, of course, it returns false. Whereas transfer, if it fails, it doesn't do anything. It just stops there. And in fact, the code will stop there altogether. It's called throw in Solidity. And this is where the difference happens, right? And this is why we were able to exploit here the false value. And here, well, we don't need that. Therefore, we use transfer instead of send. Okay, so now let's go and test this. So if I come here and I click compile, great, went through. Then I come here. So deploying, it's going to be slightly different this time. First off, we're going to be using this field here, which is value. We haven't used it previously. This field is there to actually, it will allow us to access the value that we send through the blockchain, right? So up until now, we were exchanging certain values, but this value that we were exchanging was just numbers in whatever mapping object that we selected. It wasn't really happening on the blockchain. It wasn't from my wallet, my Ethereum wallet to yours. So we're gonna change that, and we are gonna have to use this this field here to do that. Okay. Next thing as well is here you see the deploy. Oops, just deleted. If you see deploy here, deploy requires two arguments too, and they're the two arguments from our constructor function, which is the bidding time and the beneficiary. So the bidding time is going to be how long the contract is open for. And we're going to set this to, well, I think what seems reasonable is 120 minutes, 120 seconds, so 2 minutes. And the address of the beneficiary will be this one. So I copy it and I paste it here. Okay, from the moment I click deploy, we have 2 minutes. So deploy, and our contract is deployed here. So we have a few things. You see all of our variables at the bottom, and then our functions, and in red we have bid because it's a payable function. So auction end, I'm actually going to bring up the console here. So if I were to call auction end, well then it would, you see, it gives us a revert and it tells us the auction has not ended yet. And it's because our current time is still smaller than the auction end time that we're waiting for. And now what I can do is I'm going to change address to this one. And I'm going to come and put value 50. This is the amount I'm going to bid. And I'm going to come here and click on bid. Okay, I'm going to take this address just for now. And if I check who is the highest bidder, we see that it's this address here. If we check the highest bid, it's 50. And beneficiary, of course, is still the address, and auction end time is just the amount of seconds since January 1st, 1970, plus the time, the 120 seconds that we added. So now if I change address to this one, and I decide to bid this time 60, then now it went through. The highest bidder is, here we go, is no longer the same address we had. It's a different address. It's this address here. And if I check the highest bid, it is now 60. But if using the previous address, I come and check how much I have in pending returns, because we know that when we do bid and it's overbidding, well then whatever was the previous bid, it gets added to our mapping. So if I go and get the value for that address, then we see that 50 is pending return to this address. And now I can go ahead. I know that 2 minutes have passed now. I can go ahead and I can simply take another address that is, late to the party, but would have wanted to bid 100. Click on bid. It reverts. It says it is no longer possible because the auction has already ended. So that's it. The next thing we need to check actually is just, and we're going to take this address for it because it's the only address that we have in pending returns, and it's too late anyway to outbid the highest bid. It'll be 60 forever now because our auction time has ended. So if I select this address again, 8 I believe it was, yes, and I decide to withdraw it, we get a success. And if I check now how much I have in pending returns, it is now 0 because we were capable of withdrawing this property. Great. And now finally, the last thing that needs to be done, because anyway, no other action can be done apart from withdrawing, but no new bids can be done for this auction. So we can just declare that it's the end of this auction, and we were going to send to the beneficiary whatever he deserves, which in that case is 60. Auction end. It went through, no problem, and everyone is happy. There's nothing to show here because it was just 0 ways, but the right amount has been sent to the beneficiary. Okay, so that's it for today's video. I hope you enjoyed it. I'll talk to you in the next video, and until then, take care.